4. Okay, welcome to video number 2 of Lay the Foundations. So make sure you've got your notes set up. We are still under Lay the Foundations. And again, we're going to start with a warm-up. So the cost of a barrel of beans B fluctuates by 17% in both directions during a 3-month period. Write expressions that match the above verbal description. So follow the sifter method, pull out the given information, write what the question is being asked, write down if there's any formulas you need, or if there's any formulas you need to derive, and then try to solve something. To help you understand what this warm-up is looking for, write the expression. So an expression is just something that doesn't have an equal sign. 2x plus 4 is an expression. Okay, so you're trying to write a mathematical expression that matches the above verbal description. So this is a series of words, and you're trying to make it into a set of numbers and letters. Pause the video here, give that a shot, and then when you're ready, go ahead and continue. So today we're going to look at multiplication. So what is multiplication? Multiplication, right? It's just repeated addition. 2 times 2 just means, so if we zoom in here and look at this, 2 times 2 just means 2 times, right? That's why we have once and twice right here. 3 times 4, that just means 3 4 times. 1, 2, 3, 4. So on and so forth. -3 times 4 doesn't change anything. It's still repeated addition. You just have -3 4 times. Okay. Exponents, which I'm just going to introduce briefly here. 5 squared, right? Squared just means 2 5s. 5 times 5, and that just means 5 5s. So that is all multiplication is. Now, a couple of notes about signs in multiplication. Right? If you multiply the signs and they are the same, the solution is always going to be positive. Because a negative times a negative is a positive, and a positive times a positive is a positive. It's always going to be that way. Okay? If they have different signs, they're always going to be negative. Right? So let me say that again. If the signs are the same, the solution is always positive. So signs, same, always positive. Right? If they're different, always negative. Okay. Now, some of you might be wondering, why is a negative times a negative a positive? Well, it has to do with a property called the additive inverse property. Okay? So the additive inverse property says if I have some value x, okay, and I add it to the inverse of x, it needs to be equal to 0. Okay, well, we can establish from addition that the inverse of x is negative x, and that gives us 0. So that's where this idea of negative times a negative comes from. So what we're going to do is let's look at, so if we take 3 times 3, we know that that's 9. Now we get to the negative stuff. So we know that 3 times -3. Well, we don't know what that equals, right? That's the mystery to us. Okay. So that's what we've got. We don't know what 3 times negative 3 is yet. Well, we know that 3 times 3 plus negative 3, that should equal 0 because this is the additive inverse property. Well, we can now use the distributive property and distribute these. So we have 3 times 3 plus 3 times negative 3. So let's bring this up here and look at that. So 3 times 3 we know is 9 plus, we don't know what 3 times negative 3 is yet, but we know that that has to equal 0. Well, let's keep going. We can solve this. 3 times negative 3 equals negative 9. Okay. Well, we can divide by 3 because there's this 3 here, and 3 is a factor of 9. So we end up with negative 3 equals negative 3, which is true, which means that 3 times negative 3 does indeed equal negative 9. So there's your proof using the additive inverse theory about why a negative times a negative is a positive. It's not important that you need to know that, but I felt it was important that you saw where it came from. If that's something that just doesn't click for you, just remember these right here. Okay. So since we're talking about multiplication, we have to talk about the distributive property. The distributive property just says whatever happens outside of the parentheses has to get distributed to everything on the inside. Now, the big note, this only works for multiplication. There's no distributive property of division or distributive property of addition or subtraction. There's only the distributive property of multiplication. So just like before, I'm going to work the first one with you, and then I want you to do the other 3 in your notes. And if you have any questions, write them off to the left-hand side and ask them when we come back together as a class. So this first one, okay? So 2x plus 4. Distributive property says whatever happens to the outside has to happen to everything on the inside. So we're going to do this. 2 has to go there, and 2 also has to go to the 4. So when we do 2x plus 2 times 4, now we can drop the parentheses because we've distributed, and then we can just clean up 2x plus 8. That's the distributive property. Now, work on the second 3. I would pause the video here till you work those 3 out. Once you're ready, go ahead and continue. Now, what you just worked on was a monomial. A monomial, which is something with one term, multiplied by a polynomial. Polynomial is something with many terms. Okay? We can do polynomials times polynomials, and that's what we're going to look at here. Okay? So the distributive property in a more complex way, this, let me switch colors. This method right here in this box that I'm going to show you is called the area model. Okay? So the area model works off of the idea that the area of a rectangle is length times width. That's where the area model comes from. So let's take a look and see how this plays out. So when you have, we're just going to look at this first one. okay? X minus 2 times x plus 2. The area model, you assign one polynomial to one side and one polynomial to the other. So I'm going to assign x. So I'm going to assign x minus 2 to this side and x plus 2 to this side. So you take one term out of here and put it here. So I'm going to put x here. The other term goes here. But be careful. When you do this, the sign always comes with the term. So it's actually negative 2. And then if we do up here at the top, we've got x and we've got positive 2. Now, we use the area formula, length times width, and we multiply. So the length here is x. The width here is x. X times x, we've got multiplication of 2 x's. So we don't have 2x, that's addition. We have x squared. X times 2, well, that gives us 2 x's. X times negative 2 gives us negative 2x. And then negative 2 times positive 2. Think back, when the signs are different, it's always, you should be saying negative. Negative 4. Okay? Now, what we do from here, once you do this with the area model, is you scoop all of this out and you write it down. So you're going to do x squared. I'm going to go around the circle this way. 2x is positive, so I'm going to add 2x. I'm going to add negative 4, and I'm going to add negative 2x. From here, you simplify and combine like terms. So this has an x, this has an x. Negative 2 plus 2 is 0. So we end up with x squared minus 4. That's the area model. Now I want you to try the other two. I'll give you a hint on this last one with the trinomial. All that does is make the length of your box bigger. So instead of a 2 by 2, you're going to have a 2 by 3. So pause the video here. Do those in your notes. Remember, what's important is you try, and as you come to questions or you get stuck, write down what that is off to the left, and we'll talk about it in class. Okay, here's some more practice. Okay, what we're deciding is if 30x minus 12 could be a result of using the distributive property. Okay, if it is, find the possible combinations of factors whose product would be 30x minus 12. So what you're going to ask yourself is what this is saying is using the distributive property, we get to this equation. Can we undo the distributive property? Think about it, give it a shot in your notes, but we're actually going to spend some time in class talking about this. Last thing we're going to look at today is division. Okay, so division is the act of taking a number and splitting it into smaller parts. Right? Division is fractions, or conversely, fractions are just division. The idea of division is, if you've ever played a game of cards, it's like passing cards out, right? If you have 4 people playing cards and you're passing them out and everyone's supposed to get the same number, you pass out 1, 1, 1, 1, and then you pass out another one. 2, 2, 2, 2. And you keep going until everyone gets the correct number of cards. You've split the cards evenly amongst everybody that's playing. That's division. Except we all know sometimes it's not split evenly. So let's take a look. You've got some division practice. So I want you to give these a go. So 54 divided by 9, 8 divided by 11, 81x divided by 9, and x squared divided by x. So pause the video here, give those a try, and we'll talk about the answers in class. So your homework, remember, keep working on early math and arithmetic. The end of this week, we're going to take the Khan Academy, not the Khan Academy, the ALEKS Initial Knowledge Check, and we'll be starting ALEKS next week.